Jen, ma'am, you're there, right? Yes. So to tell about her, she has done her bachelor's in architecture and master's in architectural conservation, and she is currently an entrepreneur. She is a founder and principal architect in Earthwheel. She is here to explain to talk about her experiences in architectural thing related to geotechnical engineering. We welcome you, ma'am. Thank you so much.
Thank you for inviting me. Thank you very much.
Thank you. Now over to you, ma'am. You can start presenting.
Yeah. So, hi everyone, this is Akshaya. I'm an architect. I did my master's in architectural conservation, and currently I run a firm called Earthwheel, where we focus on heritage conservation and mud construction. So, good afternoon to everyone. So, in this session, I'll be talking about how temples are conserved and how the foundations of different temple vary, and how to basically approach a temple in terms of conservation and preservation of our heritage. So, as a part of Earthwheel, we have been working for the past 3 years in conserving temple structures, which are easily above 500 years ago, 500 years old, and right from the foundation up to various aspects of conservation, including plaster conservation, foundation restoration, and wall conservation. So everything we have been working on. Yeah, we have documented around 70 plus structures all around Tamil Nadu, and I'll be sharing my experience and my learning with you all in this session. So I think we can go to the session directly now. So, apart from the religious aspects of a temple, talking engineering wise, so what are all the different parts of a temple that we can see? The first, we have a foundation structure, and then the plinth structure, that what we call is adisthanam up to the base level or the plinth level, and then we have either the pillar portion or the wall portion. If we talk about pillar, we have the pillar and then the capital portion, above which we have beams, and then we have a ceiling slab, and then weathering. So here I have marked all the different parts of a temple. You can look into this, and above that we have the portion what we call as vimana. Vimana is majorly constructed in brick. Uh, there are some exceptional cases where we also have stone vimanas. Then that is in a very small count. So majorly vimanas are made of brick and lime plaster. So these are the different parts of a temple talking in a generic manner. So this is a stone structure. When we talk about a brick structure, the same thing repeats, but the wall is made of brick. So when we talk about the roof, so this is how a roof looks when the weathering is removed. The ceiling slabs are placed over the beams. So how a temple reacts is it works on the load transformation basis. Okay, so when you have the ceiling slab, the weight of the ceiling slab is bared by the beam structure. The weight of the beam and the ceiling slab is bared by the wall or the capital and the pillar, and then the weight again transforms to the plinth portion and then the foundation. So this is how a roof looks when the weathering is removed. And then comes the stone walls. So typically when people think of a stone wall, they think the entire wall is made of a single stone, but that is not what it is. So what we have is we have an outer veneer wall, and then a core in between, and then the inner veneer wall. So what we usually see is just the outer and the inner veneer stone walls. So the inside core wall is not usually visible. So this is the core wall. The core wall is usually made of debris. So either the lime and the brick bats are used in a core wall, or the stones that are chiseled away, the stone waste that we get during the chiseling or the sculpting, that is usually mixed with the lime mortar, and it is poured in between the two veneer walls. So, what we usually talk in terms of conservation is the stone walls are like the bones of a human body. So, when a bone gets fractured, it can be easily fixed. Whereas the core wall, it is called core wall because it holds the entire structure together. So, when you talk about the core wall, when the core wall is deteriorated or when the core wall is affected in any terms of vegetation or a human error, anything, when a core wall is deteriorated, you'll have to remove and reset the entire temple. But if the core wall is tight, it is strength. And if only the outer and the inner veneer stone walls are damaged, you can easily repair or restore a temple structure. So this is the inner veneer wall and the core wall in between. You can even see the case example here. Here the core is affected, whereas in this case, if you see, the core is very good. So it can be conserved very easily, whereas here the core is deteriorated due to moisture, vegetation growth, anything. So here the entire temple has to be removed and reset. So in terms of section, you can see. So any vegetation that grows only from the core wall because it has all the moisture and it
Excuse
has
me,
all
ma'am.
the feed for a
One
vegetable
minute.
to
Sorry to
grow.
interrupt. Can you just click on to that
Yes,
hide?
ma'am.
Hide.
Yes, ma'am.
Yeah, thank you.
Yes, ma'am. And also, I would like to ask: is everyone comfortable in English, or we can talk in Tamil? So, whichever language you prefer, we can continue in that. Anyone? English is fine, or can we talk in Tamil?
I think English will be better, ma'am.
Yes, ma'am. Okay. So, yeah, when any vegetation grows, it grows from the core wall because that is where the feed for any vegetation gets. So, when the stones are assembled, so we don't have any mortar in between the stone blocks. Okay, so it is just it works on the interlocking principle. So, so what they do is they keep two layers of stones, they pour in between the core wall, and then they keep stacking the stones higher and higher. So this is how the walls of a temple looks. So here an entire tree has grown from the core wall. So this has to be entirely removed and reset. So you can see here, this is another example. So from the plan view, you can see two layers of stones, and in between you have the inner core wall that is made of lime and brick, and from there a tree has grown. So it has resulted. I mean, it usually pushes all the inner veneer or the outer veneer stone walls, and it leads to the damage of the structure. So coming to the different types of foundation that we can see in temple structures. So usually, what the misconception is, what they tell is the stone foundation goes like feet, 10 feet, like 6 feet, 7 feet, or even some people say the temples have like 10 feet deep into the ground level. So that is not at all the case. So when we look here, so we have different types of foundation. One is boulder system. Boulders is stacking up all the boulders and then constructing a temple just above that. So this is one type. Boulders type of foundation can be seen in the central part of Tamil Nadu, where there are like rocky surfaces. So this is a temple near Perambalur. So from here we have observed boulders foundation. So these are the boulders, and from there they have started the Adhisthana portion, and from there the wall structure continues. Next is brick foundation. So just brick structure, you can see the brick structure, the depth of the foundation goes from 3 feet to even 5 feet. It has only brick, and from there again the brick masonry continues. This is the majority of foundation that we can see in any part of Tamil Nadu. Just one layer of stone platform. That's all. It will be around 23 to 25 centimeters. That's it. So this is the very predominant and common type of foundation that can be seen almost everywhere. And beneath this single layer of stone platform, they'll be having sand. The sand will be highly rammed or compressed, and then above that we can see just one layer of stone platform, and from there the adisthana or the plinth level starts. So you can see here, and this is another stone platform foundation that we can see, and this is just 10 centimeters depth. From here we can see the river sand compressed, and from there the temple structure continues. This is another type of foundation called mixed foundation. Here we have like three layers of a stone platform, which will be around 60 to 65 centimeters, and from there brick masonry continues beneath. So this type of foundation is usually seen in the delta regions or any regions that is adjacent to a river body. Like a river will be going beneath, or it will be agricultural land. In such places we have this type of mixed foundation. So these are the different type of foundations that are easily seen in any temple. So it is not that the foundation, how deeper the foundation goes, that much the temple structure is strong. No, the thing is how the soil is and how the load gets distributed, because we don't have any point to point load distribution, anything like that. So the load gets distributed everywhere, and the how well the soil is rammed, those things matters in terms of a temple construction. So does anyone have any doubt up to this point, or can we continue?
We can continue, ma'am.
Yeah, okay, ma'am. So we have seen the major parts of temple and how they are made, and now coming to the different damages in a temple structure. So when it comes to damages, there are majorly, it can be classified in two different types. Okay, so one is vegetation. Vegetation is the one major cause that leads to damages of any temple structure, and the next is stone deterioration or human error. Human like people will be destructing the temples. They would have added different materials over the temple, and it will lead to different load distribution, improper load distribution, and that will again lead to structural imbalance. So those are all different categories, but the major type is vegetation growth. So when it comes to vegetation growth, yeah, so a big tree has grown in between the two veneer walls from the core of the temple structure, and that has led to several damages. And in this temple case, we can also see the stones are also deteriorated or it has been corroded. This can be like what they do is they usually source stones from the local region, and when it comes to Tiruchi or Perambalur region, they have like a kind of a sandstone, or they even have fossil stones. So that will be eroding over a period of time. So for example, when you take the age of this temple, it will be around 600 to 800 years. So the stone has started to deteriorate due to the climatic changes or even the age factor. So this is how we document a temple structure and assess its condition. So what are all the different damages that are observed in a temple structure and how to treat them. So here when you see the major reason for the deterioration of this structure is due to vegetation. So what can be done is you remove both the inner and the outer veneer walls, repair the core or redo the core freshly, and then refit them. So when you come to another temple structure, example that I'll be showing you here is another vegetation. So the previous one I showed you, it was having a minimal impact due to vegetation, whereas when you see here, it has a massive impact due to vegetation. So for example, if you can see, one part of the mandapa has already fallen here. In these are how the stone structures go out of plumb. So we call them out of plumb. The stone veneer walls move because the tree here, massive tree has grown in between the vegetation here. So this will lead the stone walls to come out, get tilted, or even fall off. So you can see the stone members that has fallen off here due to the vegetation growth over here, and you can see here how it has gone out of plumb. So how can you repair this? We cannot repair such structures. Then what can be done is you have to remove and refit. So reconstruction is the only possibility here. We cannot preserve or even conserve the structure because the tree root has even gone up to the foundation level. You can see here the trees has gone up to foundation level. So one entire part of the mandapa has collapsed. And when you see so what happens is usually when a temple structure gets affected, either the inner veneer walls get affected or the outer veneer walls get affected. In such case, we can only remove the affected portion. If the outer veneer wall is affected due to vegetation, you can easily remove, redo the core and fit the outer veneer stone portions. Whereas when you see in this case, both the inner and the outer veneer walls have been affected. You can see how the foundations has collapsed, how the stone floorings have lifted up due to tree growth inside. You can see the tree grown inside the garbhagraha or the karuvarai, what we call. So how the stone floorings have undulated, and yeah, how the inner veneer walls have also been affected majorly due to vegetation growth. So yeah, this is the portion that we saw from the outer, how the mandapa walls have collapsed, and how the beam members have been broken, and how the wall structures have gone out of plumb. The entire mandapa, including the pillars, beams, and capitals, all have fallen off due to severe vegetation growth. So this is one major cause that will lead to the deterioration of a structure. So next case is stone deterioration. So for an example for stone deterioration is, you can see here how the stones have eroded over a period of time. This will be easily 500 years old temple structure. That's it, not more than that. But look at the amount of deterioration. So we won't be able to even reuse this stones when we conserve the temple. So the only thing we can do is, but if you can see, the brick vimana over the stone structure is in a very good condition. But the stones that are holding the vimana, they are not in a good condition. The stones have eroded. So what can be done is, so what we are approaching in this case is, we are planning to cut the vimana, lift it, and redo the stone structure and refit the vimana. So this is the first time we are trying to experiment in this because the brick structure is in a very good condition. We don't want to remove everything completely. So once we are able to do this, we can take this prototype in different temple structures where the brick structure is good, but the stone is not in a good condition. We'll be able to incorporate this idea wherever we can. So when you can see here, I mean, this is an example for soot deposit or how the bats or any other living being due to unusage of the temple structure. What are all the damages that can be caused? So this is surely caused due to moisture and bats. But when you see the Vimana, it is in a very good condition. So this type of stone, these are made of fossils. So when you can see different type of shells coming from the stones. You can see here. So these are like sedimented rocks or fossils that are being used for temple construction, and they erode over a period of time. So yeah, this is another case study that I wanted to show you for stone deterioration. So how can we conserve all these temple structures? Methods of conservation. So the first step is documentation and condition assessment. So how do we document a temple structure? So first is we prepare a plan layout where we'll be talking how many number of stones are dilapidated. So that will be a detailed level of document. This will be like a preliminary level of documentation where we assess the conditions. So what are all the major damages that have occurred and why they have occurred? So how to treat them? So including the cracks that have formed due to the vegetation growth, the separations that have occurred, and the fallen portions. We'll be recording everything. So this is in a plan level, and then in a sectional level. So in this we can show how the stone floorings have undulated. We can also record if there are any tilting in the walls that have been observed, and if there are tiltings you'll have to adjust the tilting. So any damages that have been observed in the temple structure will be shown in the sectional drawings. And these are the elevation drawings that we have prepared that shows different damages and the conditions and the level of condition, level of damages that has occurred. So this is the first set of restoration, that is preparation of documentation drawing and assessing its condition. And when it comes to brick structure, once we assess, so till now, I was talking about conservation or restoration of stone structures. When it comes to brick structure, how can you conserve them? For example, brick structures, as I told you, stone structures are like bones, whereas brick structures are like our tissues. So once they are gone, you have to replace them. So that is the similar case here. So in a brick structure, when a tree grows, it gets a lots of space and the moisture from the brick and the lime water to grow. So they grow vigorously. So wherever they get a chance, they grow everywhere, and they uh, like separate the brick structure and lead them to fall. So you can see the structure. It may look like it is a sound structure, it is intact, but when you like just hit the brick structure, they fall off rapidly. That is the case when it comes to bricks. So this again is an example how the bricks have separated from one another and how they are about to fall, in the verge of falling. Whereas this is a case where the core structure is sound, only the outer brick surfaces have fallen off. How can you treat such structures? If if the case is like this, you have to remove and reset. Whereas if this is the case, only the erosion has happened or only the edges have fallen off, you or there is a crack in between the structure, something like this, what you can do is you can go for stitching or underpinning. So, what is stitching? Stitching is something when you have a thorough crack in between like this, you'll have to like take off portions from different intervals and introduce a different material. For example, you can introduce stone. We don't usually go for concrete on concrete blocks. We usually go for either a lime block or inserting a stone, because that is the appropriate material you can go for a heritage structure conservation. So you can see a continuous crack here. So you'll have to remove different patches from different levels, and you can introduce a different material like a stone or a lime structure in between to stop the crack. And one thing what you have to observe is if the crack is still continuing or the crack is dead. So what you can do is you'll have to place a panel of glass in between the crack, and you can see if the glass panel has moved a few centimeters apart, or if the glass panel is also cracking. These are different methods where you can find whether the crack is live or it has stopped. So if the glass panel cracks, it means the crack is still developing. So what you can do is you will have to remove like 2 feet or 1 feet from the cracked portion, and you will have to redo the entire masonry. So that is called underpinning. Even in this portion, you can do underpinning. You will have to remove all the loose portion all of the bricks, and you can construct an entire brick wall here. And here you can also do the stitching. If the crack is dead, you can do stitching where you can introduce different materials like steel. It will look like a stapler. It will be in a par shaped stapler made of SS stainless steel or even iron. Iron will lead to it will lead to corrosion in a future period of time, but you can use SS steel for stitching, or you can incorporate different methods such as inducing stone members or lime members in between the cracks. So these are the types when it comes to brick wall conservation. And then you can grout the joints using lime plaster. We uh, we are very strict. We never go for cement plasters or concrete mortars. We don't go for that. We either go for lime mortar, lime plaster, or go for stone stitching. So when it comes to stone structures, so the first type is restoration. So how the walls are restored. So this is one example. A tree has grown from the core. You can see here. So this is the tree that we have removed from the wall structure. So this is the core in between. The core is in a very good condition, if you can see here. So what we have done is we removed the outer veneer wall. So as I have mentioned you before, the inner veneer wall is not affected due to vegetation. Only the outer veneer wall is affected. So what we have done is we removed the outer veneer walls, and we removed the tree trunk. Yeah, this is the tree, and we are refitting. So what we are doing is we are strengthening the lime core by adding some boulders or doing lime plastering work and refitting the stone members. So this is how the temple looks when the vegetation is removed, and then we'll have to refit all the removed stone members. So this is a part of restoration. And next is conservation. Conservation is, you can see how we have conserved a temple here. You can see the before and after images. Here again, the major cause is vegetation growth. So what we have done is, but luckily the inner veneer walls are not damaged even in this case. Only the outer veneer stone walls are damaged. So we have removed the inner veneer wall, we have redone the core, and then we have refitted the stone walls. Yeah, you can see how the removing and refitting happens here. And once we remove, some stone members may have broken, or some stone members need not be reused, or it won't be in a condition that it can be reused. For example, you can see here this portion, and only for those portions we'll order new stones. We'll do them accordingly with the similar measurements and proportions, and then we can refit them. You can see here. So only that portion, it will be looking in a different color, or it will be looking visually different, but that is okay. We are not reusing entirely new stones. We are reusing the stones as much as possible, and only when the places where the stones are not available, we are going for new stones. And for the counterweight, since the counterweight stones were not available, we have introduced all the counterweight stones uh, that are new ones. So, what is the purpose of counterweight? As the name suggests, it adds on to the weight of the entire structure. So, as I told you, the entire temple construction concept works on load distribution. So, how much ever weight you are giving over the structure stands still. So here we are imparting new counterweight stones to the structure, and then applying a new weathering course. Here you can see how much slope we have given. More the slope you give, the water won't be stacking on the terrace. If the water stacks on the terrace, it will again lead to water seepage, leading to damage and then dampness in the interior of the structure. So we have to give a good slope We have given around 1 to 1.2 feet slope in this case, and we do the weathering using lime concrete, over which we will be laying brick bats. Will be I mean, this is the tool that we that we use for ramming the brick lime concrete. So once you ram it well, once the lime concrete is set, we go for brick bat for the weathering finishing. And the next important part is providing stone apron. So initially they wouldn't have given any stone apron, but once you give a stone apron, what are all the advantages? It will stop water percolating into the foundation of the structure, and it will again stop the growth of any vegetation at the adjacent of the structure. So what we'll have to do is take around 1 meter to 1.5 meters from the temple structure. We'll do a pitting, and then we'll pour brick jelly concrete. We'll ram it well. So here you can see how they are pouring the lime concrete here with brick jelly, and we'll place stone flooring. So this is called stone apron. It will save the structure from water percolation and vegetation growth. Next is stone flooring. So we remove the stone flooring, and if the stones are undulated, we remove and we refit them, and we do lime grouting and pointing the joints here using lime. And this is how the final finish looks. So this is an example of conservation of a temple. And now we can come to the reconstruction of a temple structure. So where we have removed the old weathering course, this is the first part, removing the old weathering and numbering the stone members. We number from one order. Say we start from east, we continue east, north, west, south. So it will continue in one order. This is in inner veneer wall stone membering, and this is outer veneer wall stone membering. And then we provide supports for removing the stone ceiling slabs. We provide supports for the beam, capital, and the pillars. And then we remove the stone members one by one. So this is how the stones are removed. So we'll have workers who like remove each and every stone, and then the stones are carried away by the crane. You can see here, and then we'll be stacking the stone members as per the numbers that we have already made. So as I told you, this stone slab has already broken. So once we remove, we won't know how many stone members we'll be reusing as such. So for that, we can count like approximately 15 to 20 percentage we'll be using new stone members, but the remaining 80 percentage we can reuse the old stones. And once we remove, we are giving a new foundation here. For this also we are using lime concrete foundation. So we have concretized the entire portion using lime, and we'll have to allow it to set for like 2 months because the lime takes a lot time to set. So for 2 months we leave it just like that. We do the curing, and once the foundation is set, we again use boulders that you can see here. We go for boulder foundation up to the flooring level, and then we again start with the adisthanam and the wall, pillar, beam, and coming to the ceiling slab and the weathering course. So this is how the once the concrete is set, the lime concrete is set, we mark as per our drawings that we have already taken the same measurements. We mark the drawings and we set the different measurements, and we start with the foundation, and so on up to the weathering course. So that is it. How we conserve, restore, or reconstruct a temple structure, and how we treat different foundations. So this is all what we do. And when it comes to foundation, what we do is see majorly when it comes to a temple structure, the foundations are not at all disturbed. For example, I showed you one temple. Out of all the temple structure, we have hardly seen like 5 temples where the foundation have affected. Only for such structures we go for foundation redoing the foundation or strengthening the foundation. So majorly, since I showed you, since we have just one stone one stone panel that is only present for the foundation, and the foundation majorly works on how the river sand is used, how well the soil is compressed, and how well the load is distributed. It is how a temple structure works. So hardly we find any foundation damages. So only for very few temples we go like this. Else we never touch the foundation. We leave the foundation as it is. We work only on the superstructure of the temple, how we conserve it. So this is how we approach in conserving a temple structure. So if you have any doubts or any anything you want to ask, you can ask now. Anything you would like to discuss now?
Participants, the session is open for discussion.
Good afternoon, ma'am. I'm Dr.
Good
Anand
afternoon.
from Sales
Hello.
Institute of Technology. Your presentation is very nice, ma'am, and it's in a practical view only. And it's good for us to learn a lot of things.
Thank you.
Okay,
Thank you.
thank you, ma'am.
Thank you.
I think there is no other
Okay.
discussion. Yeah. So in that case, like, thank you, ma'am. Like, of all the sessions, this session was entirely in a different genre actually,
Okay.
and the before and after pictures were like, because these things we don't get to see it very easily. This is not
Yes.
a
Yes.
textbook material actually.
Yes.
So, so yes, thank you so much for giving us a very short and lot of image, lot of pictures actually. Thank you so much.
Thank you. Thank you so much. Thank you.
Thank you, ma'am.
Ma'am,
Thank you.
feedback link not at
I'll
received.
send it, sir. I'll send it, sir. I'll send it. Yes.
Thank you, ma'am.
Yes. So, for dear participants, on behalf of Veltech and Department of Civil Engineering, I'm here to say thanks to all of you for your presence in all the 12 sessions, though we had to delay one session because of rain. Thank you so much for all your cooperation throughout this 6-day FDP. Thank you, everybody. Now I'll be sharing the feedback session. The participation certificates will be sent within 10 days in email. Anything else to be discussed? If there is nothing, we can wind up the session. Once again, thank you, Akshaya ma'am, for spending your valuable time with us. Thank you.
Thank you, ma'am. Thank you so much.
Thank you.
Bye.
Thank you, participants. Thank you, everybody.